Hi everyone, it's Miss Wong here. We're going to be going over position versus time motion graph. And this is a graph for the practice number 1 found in your second week's folder for motion graphs. So let's go over these questions. Use the slope to determine the average velocity of the object during the first 4 seconds. So during the first 4 seconds would be here to here. And we're going to compare and use these values to calculate for our average velocity. So average velocity was that slope formula, rise over run, and our rise is always going to be the y-axis over the x-axis of time. So average v equals the change in displacement over change in time, df minus di, tf minus ti, and you will get a df of 0 meters minus a initial of 10 meters over tf of 4 seconds minus 0 seconds. You'll get minus 10 meters over 4 seconds, which leaves you a minus 2.5 meters per second. So this minus 2.5 meters per second doesn't make sense with the graph. Yes, it does, because in parts A to B here, you have a flat horizontal line, meaning there is 0 velocity there. Then B to C, we notice that the line is heading towards the x-axis, therefore the value should be negative. And it is a straight line, so it should have a constant velocity. So any of these points will give you the same answer of negative 2.5 meters per second. It's negative because it's heading towards the x-axis, so we should calculate a velocity that is negative as you are moving backwards. Alright, so the next question. Use the slope to determine the average velocity of the object between D and E. So D is right here, E is here. We need to find the velocity of this line. Is it constant? Yes, it is, because it is a straight line that is diagonal. Therefore, we can pick any of these points to solve for velocity, and it'll give us the same value. Will it be negative? Yes, because it's in those negative position values going backwards. The only time when we can't choose for sure points, like at these intersections, is when we have that curved line, because that means the velocity will be different at all these different points. Therefore, you have to create that tangent, okay, and make a rise over run triangle at that point and plug in those values. So you'll see that in your assignment when you have the points that you plot on the graph form a curved line. But this question does not ask for that. So we're going to plug in the values of D to E to solve for our average velocity. df di over tf minus ti. So we plug in our values of our final, which was 16 minus meters, our initial of 0 meters over our tf of 6 seconds, minus 5.5 seconds, and you get minus 16 meters over a 0.5 seconds, and the answer that you should get is minus 32 meters per second. All right, does this value make sense? Yes, it's negative because of those negative values that we're plugging in for position, which makes sense. We're going backwards. And 32, does it seem steep? Yes, it does, because the line is very vertical. It's almost at a 90-degree angle. Therefore, it's super steep. And we can expect that the velocity would be much bigger than B and C, because this object is moving super fast during these points right here, okay? What is the object doing at points A to B? How do you know? Well, the object at points A to B is not moving at all. It's staying at 10 meters during this time period of 2 seconds. It's constantly at this position, so it's constantly at 0 velocity, okay? It has 0 velocity for this entire line. We know that because it's a flat horizontal line. What is the motion at G to H? Is it uniform? Okay, explain. we also want to find the acceleration. It kind of got cut off here. So at G to H, is it uniform? Yes, it is, because this is a straight diagonal line going away from the x-axis, so we can expect that it's going to be positive velocity, and it's also a constant velocity because of that straight diagonal line, and it is also uniform. It's uniform, meaning any of these points that we take to plug into that slope formula will give us the same number. T will give us the same number because it's uniform, because it's a straight line. So let's solve for that acceleration then. So, sorry, not acceleration. Let's solve for the velocity. Velocity equals d over t. We're going to talk about acceleration in just a little bit. df minus di over tf minus ti. You're going to plug in those values from G to H, and you're going to get 14 meters minus 0 meters over 11 seconds minus 9 seconds. You're going to get 14 meters divided by 2 seconds, and then your average velocity for G to H will equal 7 meters per second. Awesome. Does this make sense? Yes, it does, because it's a positive 7 meters per second for the velocity going up to G to H, and it is constant. So anywhere along here, we can grab those numbers and get 7 meters per second. Now let's talk about acceleration. How are we going to calculate this? Well, we don't really need to calculate it, because if we know this is a constant velocity, is it accelerating? Well, during this time, it's constantly traveling at a 7 meters per second. Therefore, we have no acceleration. That 7 isn't changing within this line. Therefore, our acceleration should be 0. That is how you would find acceleration. Alrighty. Well, you guys have a great day. I'm going to answer the next question or next practice problem, which is the same graph but for velocity versus time. Have a great day.